Now we'll move along to this next example on the first page here. We want to solve this to the nearest hundredth of a radian. We've got cos squared x minus, 6 cos squared x minus 5x minus 6 equals 0 on the same domain. So we need to factor this. So you can either use decomposition or sum across products. So please pause the video and factor this. If you wish, as an intermediate step, what you could do is you could change this to 6, say y squared minus 5y minus 6 equals 0. Solve that. That would be letting y equals cos x. Factor that, and then replace the y with cos x back in here again. Okay, so pause the video now and please factor that. Okay, so now that that's been completed, check here, we've got 2 cos x minus 3 times 3 cos x plus 2 equals 0. Should be cosine there. And again, we've got two factors that multiply together to give you 0. Either one factor equals 0 or the other factor equals 0 or both. So we'll take this, we've got 2 cos x minus 3 equals 0 and 3 cosine x plus 2 equals 0. Now we can solve them both for cosine x. So we've got 2 cosine x equals 3. Divide both sides by 2, so we get cos x equals 3 over 2. And then over here, do the same thing, 3 cos x equals negative 2. Divide both sides by 3, so we get cosine x equals negative 2 over 3. Now take a look at these two results. And what do you notice about this? Think back to the basic cosine function, the parent function, between 0 and 2 pi. What do you know about the values of cos x? Okay, so undergoing no vertical stretch, the maximum value of cosine is actually 1. So because this is greater than 1, therefore this is undefined. So we can't use that anymore. This one, however, we can use, and because this is 2 over 3 is not an exact value of special angles that we know, so we're going to solve this to the nearest hundredth. So you're going to need to set your calculator to radian mode to make sure about that. And the negative will give us an indication where the terminal arm would be. So according to the CAS rule, where would the terminal arm be when cosine is negative? Okay, so we've got it in quadrant 2 and 3. And so I'll do it a little differently this way. So x2 is from the positive portion of the x-axis around the second terminal arm, and x1 is from the positive portion of the x-axis to the first terminal arm, and in here is the beta angle, the related acute angle. So if you find cos beta of 2 over 3, you do the inverse cos of both sides there, and beta is 0.8411 radians. Then x1 is pi minus beta, which is 2.30 radians rounded to the nearest hundredth. And x2 is pi plus beta, and that gives us 3.98 radians rounded to the nearest hundredth. Okay, so now this example, we'll do the same sort of thing again. We'll try to solve a complicated trigonometric expression. So we've got 3 sine theta plus 3 cos 2 theta minus 2, or equals 2, sorry. Again, we've got a single angle here, and we've got a double angle here, so we can't mix those two together, they're unlike terms. So what we need to do is change this double angle into a single angle, and because we've already got sine here, that should guide us with which of the 3 double angles and cosine that we need to use. So let's rewrite this. I'll just rewrite it over here to give us some room. So 3 sine theta plus 3 cos 2 theta equals 2. And then from the double angle formulas, we've got 3 times 1 minus 2 sine square theta. And then you just expand this out and simplify it down a little bit. Okay, please continue that and get it into standard form that we would use for quadratics. And then just multiply through by a negative here. Okay, so now we've got a quadratic here in terms of sine theta. Let's see if we can factor this down to get 2 factors. So pause the video please and factor that, and then come back and check. So after using either decomposition or sum across products, looks like this cannot be factored. So we'll use quadratic formula. So it works the same as when we're solving it using x. We got sine theta equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll just simplify this here. So sine theta then is 3 plus root 33 over 12, or 3 minus root 33 over 12. Okay, and when we work this out, rounded to 4 decimal places, actually I think I'll round it to 6 just for fun, for more accuracy. This gives me sine theta equals 0.7288714, and this gives me negative 0.228714. So now, when the sine of some angle gives us a positive ratio in radians, we know that there are 2 possibilities where that angle could be, and when it's negative it can also give us 2 possibilities where that terminal arm could be. Okay, so when it's positive, it's either in the first or second quadrants, and if it's negative, it's in either the third or fourth quadrants. So here's angle beta, a related acute angle, and here's also actually theta 1. Here's a related acute angle here also, and this is theta 2 all the way from here all the way around to there. And we've got angle beta here, and all the way around to there is theta 4, and here to there is theta 3. Okay, so then sine of beta is 0.728714. So beta is 0.8164 radians. Over here, sine of beta is 0.228714. So the actual beta angle, when you do the inverse sine, is 0.2308 radians. And so theta 1 is the same as beta, 0.81 radians. And theta 2 is pi minus beta, which is 2.33 radians. Then over on this side, theta 3 is pi plus beta, which is 3.37 radians, and theta 4 is 2 pi minus beta, which is 6.05 radians. Okay, so those are all the examples that we will need to work through. Your class time fun is, this work is given here. Please work on the first few at home and come in to class to finish off the rest. And so there is the review time fun, which you can take a look at to begin reviewing for the test, plus there's some additional worksheets which will help you prepare for the test also. So thank you for your attention, and we'll see you in class.